HS equation. Okay. HS manufactures components. HS manufactures HS manufactures components for use in computers, and the business operates in a highly competitive market where there are a large number of manufacturers of similar components. HS is considering its pricing strategy for next 12 weeks for one of its components, and the managing director seeks your advice to determine the selling price that will maximize the profit to be made during this period. You have been given the following data: market demand, current sales price of the component is 1350, and at this price the average weekly demand over the last 4 weeks has been 8000 components. An analysis of the market shows that for every 50 increase in the selling price, the demand reduces by 1000 components per week. Equally, for 50 reduction in selling price, the demand increases by 1000 components per week. Costs: the direct material cost of each component is 270, and this price is part of the fixed price contract with the material suppliers, and the contract cost does not expires for another year. Production, labor and conversion costs together with the other overhead cost and the corresponding output volumes have been collected for the last 4 weeks, and they are as follows: week 1, 2, 3, 4 output volumes 9400, 7600, 8500, 7300. Okay, no significant changes in the cost behavior are expected of over next 12 months. So the first part of the question is asking calculate the optimum profit maximizing selling price for the component of for the period. Okay, fine. So what is the profit the price equation or the demand equation which can maximize our profit? That is P is equal to A minus BQ. B is the changing selling price over the change in quantity demanded. So this is the information which has already been given over here, and it is 50 upon 1000, and this will be 0.05. So we have B. Do we have Q? Yes, it's 8000 components. Okay. But over here, if we read this information, it is written that the current price of the component is 1350, and at this price, the average weekly demand is 8000. Okay, so we have the price as well, 1350, and at this, the demand is 8000 units. So A is something which we need to calculate, and B we have calculated just above, and this will be multiplied by 8000. So we can get A, which is 1350 plus 400. So A is equal to 1750. So the demand equation which will maximize our profit will be P is equal to 1750 50 minus 0.05 Q. So at which quantity our selling price will generate maximum profit. We will calculate further. Now further they have given that the direct material cost is 270. So we have been given some information about the variable cost as well. So one information we have that we have direct material cost. Okay, if we have direct material cost, is this information enough? What other information is given? One information which is given is production labor and conversion cost together with the overhead cost and the corresponding output volumes have been collected, and this is the information which is given. That means we'll have to calculate the production labor and conversion cost. These are semi variable cost, and we will have to calculate this with the help of high low method. So if we need to calculate the variable cost, we have been given the direct material cost, direct material cost is what, 270. If direct material cost is 270, what is the cost of no, not if, matlab, what we need to calculate is separately the variable cost of production labor and conversion cost, because it's a semi variable cost. All right, so the highest demand is 7,300, the lowest I mean, and the highest is 9,400. So I am calculating now variable cost of production and conversion. So the highest is 9,400, lowest is 7,300. Difference between both of them is 2,100. So this is the units. And if I talk about the cost, highest is 7,000 and lowest is 5,446. So the difference in the cost is 7,000 minus 5,446, which is 1,554. So the per unit, so the variable production cost is 1,554 divided by 2,100. This is this much. Okay, this is highest and this is lowest. Now what else we need to do? Now we have got the variable production cost. We've got the variable production cost. We do not need the fixed cost, so we'll stop this high-low method calculation over here only. If this is 0.74, how many units are there? How many units are there if the demand increases? So I will multiply this by 1,000, because the demand is increasing by 1000. So the variable cost of will be 1000 into 0.74, that is 740. So now the marginal cost will be 270 plus 740, which is 1010, and marginal cost is equal to marginal revenue, and the marginal revenue equation is A minus 2BQ. Okay, so marginal revenue is 1010 and A has already been calculated as 1750, and 2 into 0.05 into Q is something which we need to find. Q is 7400. I will replace that in my demand equation, which was over here. And 380. Okay, we have calculated the optimum selling price now as 1380. Next part is identify and explain 3 reasons why it may be inappropriate for HS to use theoretical price model in practice. Okay, so there are number of reasons why it may be inappropriate for HS to use this model in practice. The model depends on the market structure being one in which there is a perfect competition, monopolistic competition, monopoly, or oligopoly. While the market is highly competitive, it is unlikely that there is perfect competition, and so it would not be appropriate to apply theoretical pricing model over here. The model assumes that the cost and demands follow a linear relationship, and that there are also no step changes in the fixed cost. Again, this model holds over a small range of volume but is unlikely to be true for all possible volumes. Okay, so this model can also be used if the company has detailed knowledge of demand and cost curves. It is unlikely that in practice HS would be able to derive accurate cost and demand curves.